Thank you all for joining us. This is the second webinar in our Basics of Agriculture for Conservationist series. And we are happy to have Judy Derricks and Terry Kelly from NRCS to talk to us about conservation planning. So Judy, feel free to take it away.
Okay, thank you so very much, Christina. I look forward to spending the next hour with all of you. I know that there's probably a variety of experience and skill in the audience, so feel free to interject with questions or concerns as we go through, or maybe some positive comments would always be welcome. So what we want to do today is we want to just basically touch on the concepts behind conservation planning, and as time permits, visit the field office technical guide a little bit, kind of focus on maybe practice 328, 329. Those are conservation rotations and tillage if we have time, and talk a little bit about the planning process from an agency perspective or from a conservation planner's perspective. The goal here is to prepare us to do a good job when we are out on the land working with our producers and get us ready to understand some of the basic concepts that we need to tackle before we start working with our landowners. So I just want to give that basic information. So what is conservation planning? And basically it is a process, and NRCS is starting to really focus on what exactly is that process and tearing it apart piece by piece to make sure that we restructure ourselves to understand all the parts of planning and not just dealing with the producer that walks in the office and wants a specific item. But we want to step it back and say, what historically has conservation planning been about? And are we fully doing a good job looking at all the pieces of conservation planning so that we are looking at resource management and resource protection all across the state? So that's going to be kind of the focus on how we go about things. We're going to look a little bit at the history of where planning has been in Wisconsin, and then a little bit about what we're trying to do to restructure and make sure that we're really in tune to all the parts and pieces of good conservation planning. So the bottom line is that we can grow conservation stewardship on the land. So that's what we're going to attempt to do today. Okay, so the objectives today will be looking at planning ideas and solutions to the challenges that we will all face or have faced on the landscape. Understand resource concerns and understand what are the steps to good conservation planning. What are some of the options? What is it I can offer? How can I handle the changes that are going to be needed to make sure that the landscape is protected for future generations? So we're going to have a focus on sustainability and on resource management today. So we're going to start looking at past history. This would be a slide that was one of the original reasons that the Soil Conservation Service came into being. And we all know the history of the Dust Bowl era and some of the conservation issues that surfaced early in the Wisconsin history. So this one is not the Badlands, but this is what Wisconsin looked like at one point in history. So we kind of all had the feeling, historical perspective of what happened when we weren't very knowledgeable about soil protection. But even today, it still can look like that, probably on a smaller scale, but anything is possible. This is just a picture of a major rain event and some of the outcome of that major rain event for a producer. So anything is possible. You can walk into holes bigger than school buses, holes as big as a building, caused by any number of rain events, and it's happening all across Wisconsin. So we are going to be looking at our purpose and our function and what we do when we encounter challenges out and about. So we've talked a lot about this thing called a planning process, and what I want to assure you is it is nothing new, but this is what good conservation planning has always been about. So there are 9 steps to good conservation planning, and I just want to spend a little bit of time right now talking about what those 9 steps are. The 9 steps come and go. You go from step 1 to step 5 and back again and back and forth. So it's not anything that's in any kind of serious order that you have to follow. But what we have to do is be aware of the different pieces of what good conservation planning is. So I'm just going to cover this real briefly and tell you that we spend an entire week focusing on some of these steps, making sure that we get this figured out. So step number 1 is identifying what the problem is. And that sounds simple enough. But what it really is making sure that we look at it objectively and we look beyond what the obvious is. So we may have a producer walk in the office and say, I've got a big problem and I need a waterway. That's not necessarily reflecting what the problem is. What we have to do is step back long enough to figure out what caused it, what's going on out there, so what is the real problem? And that takes a little bit more time than one would think. We don't just prescribe the solution. We quickly step back long enough to look at the uplands, to look at the soil structure, to look at the planning that has been going on, and to look at what exactly is causing the difficulties that they're having out there. So that's called stop and identify what is the real problem. It isn't necessarily the waterway that they walk in wanting fixed. It may be upland treatments, it may be soil quality, it may be a lot of things. So stop and look and figure out what really is the problem out there. The second one is determine the objectives. The objectives are always the landowners to own. Sometimes we like to prescribe the solution and tell them this is what you need to do. They don't need to do anything. They have the right to do absolutely nothing and deal with their problem. So sometimes we've got to step back long enough to understand that we have to look at the objective from the landowner perspective or our client's perspective. Why is it that they need to address this problem? What is it that they are looking for? So get inside their processing and work with it from their perspective and their vantage point so that they want to do what's right and what they can afford to do. The third step is to inventory the resources. That's to really start assessing to figure out, so what do we have out here and what do we need to know about this circumstance? So we need to know a lot about the soil because the soil is the bottom line to everything we do. Whether it's engineering or whether it's growing something, the soil will dictate our success. So we need to do a lot to inventory our resources. It may be looking at the topography, looking at the watershed behind it, getting a good runoff curve number. It's all about inventorying resources and knowing what is on that landscape and what the interactions are of those resources that we need to inventory. Then there's a lot that we need to do to analyze what it is we just gathered. So what impact is this having? What impact is that having? What do we do with all that material? How does that affect where we're going with this conservation planning? Step number 5 is really important because we don't just dictate one solution fits all. There are many solutions to every single problem. So I'll take a manure storage, for example. That's a wonderful solution. It puts your manure 6 months in storage, makes life on a daily basis real doable, but I will say that is not the only solution to manure management. So sometimes you've got to step back and realize there are other avenues, there are always choices, and we should always be looking at options for a landowner. In conservation planning, that's critical because we always need to provide opportunities and let them choose what works best for them. So for example, we may think that no tillage on this steep field is the absolute answer. But if it requires them to purchase new equipment that they cannot afford, it may risk putting them out of business. They aren't willing to do it because maybe their management isn't quite ready for something as drastic as that. Okay, so what are the other options that we have? Maybe hay is a better option for those folks. maybe putting it into CRP. Maybe there's a lot of different options, but we need to explore multiple alternatives. We don't just offer one, but we say, well, these are the different kind of alternatives you may want to consider. This one would be better than that one as far as addressing this particular resource concern, but these are available options to you, and we always suggest they also have the option of doing absolutely nothing and then dealing with the consequences of not doing anything. So we want to focus a little bit on what are the alternatives that they can look at. And then I guess I jumped a little bit ahead, evaluate the alternatives. So I'm going to choose to do absolutely nothing. What's it going to cost me? I've got gully erosion. It's advancing at 10 feet a year. And it's so many feet wide, so many feet deep. I can figure out maybe my erosion rate is 75 tons per acre. So if I do nothing, excuse me, will this ever stabilize? And if so, when? And how much soil will I lose? So those are the evaluations that we're talking about. What if I choose to put a grade stave on there? That's an alternative. Will that do the job? And what will it save me? What will it cost me? So what are my long-term benefits? What are my short-term costs? And then number 7 is the decision-making. So we lay all the options out, then the landowner, the producer, our clients, they're the ones that make the decisions on what it is that they're going to be doing. So we want them to make the decision, but we want that decision made after they understand all the possible alternatives and what ones would fit the best in their world. So from making that decision, we move into implementing the plan, and that's the part where we usually think in that spot because we spend a lot of our energy there. We put the design together. Once the decision is made, we start to do the design itself. So we start to put together the job sheet. You're going to plant this, and you're going to your contour buffer is going to go here, or your waterway is going to be centerline here and stationing, and this is what your grade is going to be. So that's the implementation piece of it, and we spend a lot of time in that phase, but all the other 7 phases leading up to step 8 are critical as well. And then we have finally the evaluation phase, and we sometimes refer to that as the stage that often doesn't happen. But the evaluation stage is really critical for all of us as planners to know that we fixed it, it actually worked, their operation and management is functioning. So what we had planned worked for them. It was a good plan. We learn a lot about that particular practice that we just installed based on our step 9. So there you have the 9 steps for conservation planning. And they are not new, and they're not just for NRCS staff. They're just basic, sound, historical background to what good conservation planning should be. All right, in the planning process, we have a producer that's on top. That person makes the decisions. We have the planner that helps formulate the decisions by offering all the alternatives and really analyzing the circumstance. Sometimes the producers, the owners of the land, are the worst possible people at trying to figure out how to fix it, because whatever it is, they've lived with it for a very long time. They may not even see it as a resource concern because they've walked past, let's say it's a bad barnyard. They've walked past that barnyard for the last 40 years, and before that, they watched their dad walk past that barnyard for a few years as well, and nobody really sat back to figure out how can we do this different? Are there other alternatives? So you as a planner have a huge role there because you come into the scene with open eyes and new ideas to introduce to the producer. And then of course we have the land, we have the farmstead itself. So those are our 3 pieces of the conservation planning puzzle. And then NRCS and all of us need to be thinking about, most of you are very aware of what documentation is because that's become a word that's really critical. And the thing that I like to talk about is the importance of it from a historical perspective. Because I've worked with a lot of landowners that sometimes it almost takes a whole other generation before they really dive into making a change in a positive direction for resource management. So what we refer to as a Conservation 6 note is simply that. It's a historical document of who is suggesting what decisions are taking place, and so what we should be able to do by reading the Conservation 6 note is kind of have a running log of the thought process that are going into conservation planning. That's the most important reason for doing documentation, is to give us that historical perspective. Well, I suggested this, and as a result, this is a choice that was made. And then 2 years later, something else happens. And when you get that historical perspective, you can start to see what has been working and where to take the conservation planning. So that's one of the things that we talk about in documentation. And then on this side, we have this thing called the CPA 52. We're starting to talk about that a lot, but what I will tell you about that is it forces us to think about 9 steps of planning, not just what do you want? Okay, we'll design that for you. So that's that. And then we talk a lot about resource concerns. And all of us know what resource concerns are, but we're starting to define them so that we're thinking about all the resource concerns as we go down through. What impact am I having on soil? Water, we think about a lot because water quality is so important to Wisconsin, surface and groundwater. We talk about air, especially when we've got wind erosion or we have odor issues. Plants are something that we probably need to focus more on as we go. We think a little bit about invasive species, but sometimes we don't think very much about what is the quality of the plants in the pasture. How do the plants look during August when water's short? And is that related to soil? Is there something we could do from a soil health perspective to enhance the condition of the plants in August? The crops. Animals, okay, how are they looking? What are, what's going on with animals? And that can include wildlife, pollinators. Energy, that gets more attention all the time. And then there's the human side. What is it that we can do to enhance the human side of conservation planning? And then we have this thing called the National Planning Procedures Handbook. We refer to it as NPPH. If you've never looked at that book, that's a very historical document of what has successfully worked in conservation planning and what hasn't. I'd highly recommend that you open that book up sometime and start to look at it. That's where you get a big appreciation for history and conservation planning as it relates to those 9 steps that we outlined. So in the National Planning Procedures Handbook, it refers to resource concerns, and everything that we are going to start to look at as possible solutions in the planning process evolve around resource concerns. And we've identified, lumped together these resource concerns, and there's 9 of them. Soil erosion, plant condition. These are things that we have to be thinking about as we do total resource management planning. What is the soil erosion that's going on out there? What are the plant conditions? Do we have a problem with some of the plants' productivity and health? Are there pest pressures? And you bet there's pest pressures. We're starting to see more and more resistant varieties of weeds that are pressuring our crop fields. So there's all kinds of reasons why we need to pay close attention to the NPPH resource concerns. Soil quality. Do we have compaction issues? Do we have surface crusting? Is our organic matter depleting itself over time? Habitat for fish and wildlife. We're starting to get real concerned about pollinators as a state. We need to be concerned about pollinators, wildlife habitat. insufficient water, what's going on, or do we have excessive water because it's running off and ponding because it can't infiltrate, because we may have some issues with our soil. Livestock production, do we have enough feed? Do we have enough water? Do we have problems with our shelters? So we have water quality degradation, and that we become very familiar with. Are we increasing water temperatures in our trout streams? What are we doing with pests and nutrients in runoff? Air quality, that gets a lot of attention as well when we're conservation planning. And then inefficiencies in the energy arena. So I want to spend a little more time defining what an existing resource concern is. So when we see a concern, and this is obviously two examples of a concern, we have one on the right-hand side where we have probably some, on the top photos, probably some lateral flow in some soils that have some pretty poor structure. So it's starting to collapse and cause failure. So we're losing it. Could be spring frost causing it. Probably isn't a lot of surface water, although we tend to think that when we see big erosion problems like this, but something's causing a major failure. So we got problems with lateral flow now. It looks like a sandy site. Could be 101 things, but that's what resource planning is all about. Try to investigate what exactly has happened there, because that's a pretty serious problem for a producer. And then the other photo there, we're looking at, wow, we can see obviously that infiltration rates are a problem. What's going on to cause it is the part of planning that gets exciting. So we've got a lot of things going on when it comes to conservation planning. But the first thing we have to do is define what it is we're seeing. And that definition is called a benchmark condition. This is what I saw the minute I stepped on that property. The time that they asked me for assistance, this is what it looked like. That's called a benchmark condition, the original condition. And we need to do a really good job looking at soil, water, air, plants, animals, energy, and humans when we define those benchmark conditions. And all of this information is in Section 3 of the resource concerns for Wisconsin are listed in the Field Office Technical Guidance Section 3. So that's kind of interesting reading if you've never been in there before. I would encourage you to go inside there. So we've got a lot of resource concerns going on here. The top photo A, we've got soil erosion, we have sheet erosion, we have rills, we have gullies, we've got it all there. We've got sediment traveling off site, we've got a mess. So we need to do a lot of planning to figure out what caused it, what's really going on here, and what exactly is that benchmark condition. We've got every kind of erosion happening at a rapid pace. Photo B is another kind of planning, and that's soil wind erosion that's going on. So we need to get a handle on our wind erosion issues. Saltation for crop damage and other things are concerning. Say nothing about the air quality that is pretty obvious there. So picture C, they're looking at after the wind dies down exactly what happened to the plant condition as a result of that wind erosion issue. And then we have some pretty obvious water quality degradation problems with a feedlot that has some surface flow off of it and not a whole lot of filtering going on. So those are some typical resource concerns that we may see. These are kind of the fun things, the befores and the afters when we're actually conservation planning. So the photo on the left is gully erosion that's gotten out of control. Obviously a need to stabilize that grade and get some sod on there so we can stabilize that site. And then no doubt by the time you get to the bottom of that slope, it's going to look like it's you're really dropping fast and you have no control. So shaping it may not be enough. You may need to stabilize it with a grade stable structure, something that actually controls the end so that grade is under control. So these are the results of conservation planning, but we always have to look above it to see what's causing it and what exactly is going on out there. All right, so erosion prediction we want to spend a little bit of time on today. And so the first thing we want to do is figure out exactly what's going on. And the only way to do that is to really do a good job of interviewing our landowners. So we're going to look at a whole lot of stuff. We're going to look at, and when we get to the field in this course, we're going to be looking at significant issues that are associated with that planting area. What is going on there? What's the length? What's the steepness of the slopes? Excuse me, what crops are growing and what has been growing over the past few years? What are the sequencing of the crops? What are the tillage practices that are going on associated with the crops? What are the yields? What are the soils telling us? And what are some of the supporting practices? So I'm going to turn this over to Terry at this point, and he's going to start talking about erosion rates and contributing factors to erosion rates.
Good afternoon, everyone. I would think most of you know me. If not, my name is Terrence Kelly. I am the state agronomist here, working under Judy Derricks and the resources staff. And so just briefly, just give you an overview of erosion, the erosion rate, and really how we can prevent it. By looking at this slide, you know, oftentimes when it comes to assessing if we have a resource concern, most of the time when it's erosion is visible. I mean, it's something that we can see. It's obvious that it is occurring, and it is occurring at certain times under certain conditions for certain reasons. And so it's very easy for us to identify soil erosion as a concern. However, as Judy stated during her presentation, in terms of how can we combat soil erosion, when you think about erosion or soil sediment leaving the field edge, a farmer's field edge, most of the time, the majority of the time, poor water quality depends on how we have upland treatment in the watershed. And so as we look at the factors that are involved in making every effort to combat, in this case, we're looking at gully erosion. However, gully erosion can result from a combination of a sheet and reel until we have concentrated flow leaving the landscape. So with the universal soil loss equation, we have, it's an empirical tool, empirical formula, and what does that exactly mean? That there are some data points tied to each one of those factors, RK, LSC, and P. The climatic factor is most challenging, and one that we probably don't spend a whole lot of time thinking about, but just let me give you just a brief overview of the R factor. It relates to the amount of rainfall that we get per year, and typically in Wisconsin we get anywhere up to the average is about 31, 32, 33 inches a year. Now that climatic factor that is embedded in Russell 2 looks at a distribution curve for Wisconsin, or even in our region, of rainfall events over a 24-hour period, with the majority falling within 12 hours of that rainstorm. So at the 12th hour of a 24-hour rain event, most of the water would have fallen. The majority of it would have fallen on the landscape. What's also embedded in the rainfall factor is what we refer to as 30-minute intensity ratings, which is again embedded in the R factor, meaning that that storm event that has a quarter of an inch or more of rainfall within a 30-minute period is embedded in terms of helping us to understand what we refer to as an erosion index that is assigned to within Russell 2, okay, in the R factor. We will not be updating any climatic data anytime soon, although we do have some new information available that can be used to further fine-tune rainfall events as they occur. The soil erodibility factor, or the K factor, think of it this way. As you move from a clay to a silt to a coarse textured soil such as sand, the erodibility factor is much higher for silt loam soils, okay? So soils that have a high K, in Wisconsin we can be up to a 0.43, and what that means is that there's a ratio of the soil and the slope steepness, okay? And then it's tied into rainfall events. But the soil erodibility factors, if you keep one thing in mind, is that that number for that K factor is most erosive for silt loams. Now, the length and steepness factor, referred to as the LS, and so that kind of drives when we as planners select the most dominant critical soil. And the dominant critical soil directly relates to really how steep that mapping unit is, for the most part. There are some exceptions, but however, a steep soil type, a mapping unit, really is going to result in excessive erosion if we do not have the practice in place to reduce the erosion. Another important factor, which is crop rotation and tillage. Now, U.S. planners have control over what we refer to as the C factor, or the management factor, that deals with the crop rotation. How long are you going to have perennial crops on the landscape versus annual crops, and really what kind of tillage system you are going to have in place, okay? And so that's the crop management factor. But keep in mind that within the universal soil loss equation, you as a planner and the producer have control over that C management factor. Also, the supporting practices, and we have a wide range of supporting practices: contour buffer strips. We have what we call contouring, meaning that we are going around the slope perpendicular to water runoff. Contour strip cropping, terraces fall into that category of supporting practices in which we can cut that LS, or that slope, in half. So again, what two variables within the universal soil loss equation that you as a planner and the producer has control, which is C and P. Here's an example, and I know most of you have seen this slide before, but within Russell 2, Russell 2 does not compute ephemeral erosion. What it does is it computes what we refer to as sheet and reel erosion that runs off the landscape, in which there is no gully erosion. So Russell 2, in the future, we are hoping that it will be able to give us some type of output data as it refers to ephemeral or classic gully erosion. So what you see in this slide is an example of reel, what we refer to as interreeling. You see ephemeral, and you see gully. Now, one of the things with ephemeral, we expect it to occur for the most part in the same place every year, year after year after year. And usually what can happen with ephemeral erosion is that it can be covered up. But the following crop year, it will occur again, more than likely. In terms of classic gully erosions, typically the farmer can't just close it with tillage tools. So some additional steps may be needed to solve that resource problem. Here's an example of significant planting area. Sometimes significant planting area can be a little challenging in that we may have an area that is 4% at 250 feet that may be in this example, 40% of the area, but it may be adjacent to a environmentally sensitive area, such as a wetland or near a perennial water body. And so we may be treating that landscape 8% 200 feet, 6% 200 feet in slopland to a certain soil loss. But do you know that perhaps 4% at 250 feet, the sediment delivery to that protected area may be higher? So yes, when we talk about significant planting area, it is important. And just as a planning technicality, when we plan for the worst case scenario, meaning that we select the critical dominant slope. And so if you look at this slide, it would be 8% at 200 feet. So if we treat that soil mapping unit, okay, more than likely, we're going to take care of the 4% at 250 feet. However, that being said, we probably need to look at an assessment of the 4% at 250 feet that's right adjacent or contiguous to a perennial water body. Types of water erosion, I think I kind of alluded to. We have sheet and reel, okay? And just as a side note that most of our soils in Wisconsin, the crop productivity index, which is the T factor for that map unit, ranges between 2 and 5, okay? 2 and 5. And so sheet and reel erosion, a soil that's losing 5 tons per acre per year, just imagine that being the thickness of a silver dime over 1 acre. So a football field is about the size of it's about 1 acre. Here we have ephemeral erosion, where water concentrates usually within 300 feet after overland flow, or sheet and reel flow off the landscape. Next slide. Oh. One of the difficulties, I think I stated before, it's pretty obvious when we can see the erosion that's occurring on the landscape. However, if the first picture there with the producer looking at sediment that has been delivered from the uplands, wondering what can I do to address that issue. This is an example where no-till perhaps will not solve that problem. Okay, so it may have to be a combination of practices, or it may have to be a situation where the producer is willing to, or he or she can afford to perhaps put a grass waterway in and take land out of production just to address that resource problem. The next slide looks at, again, sediment that is carried off the field. And sometimes what we fail to realize is that, you know, our universal solvent, water, dissolves everything. And it moves everything. And here we have out-of-bank flow. And so if a producer put shear start sprayed for his corn crop, more than likely if it was surface applied, we had rainfall events that is delivered off the field. Or if somebody went to spread, okay, within a surface water quality management area. And so doing spring runoff or doing high rainfall events or flooding events, well, guess what? We know where those constituents are delivered. Next, this slide here is an example of, it looks like no-till. I'm not quite sure, but no, it's a degraded soil resource. Quite often, when you see the hillsides that fire up in July, there is a resource concern, and it's lack of water. However, it could be a combination of little or no organic matter, and maybe what we have to do is do some things that would enhance the water holding capacity of that soil. And so the resource concern here may be plant degradation, okay? And so what are the things that we can do to address that resource concern when it comes to soil organic matter? More than likely, manure application, growing perennial crops, and no-till. And then the next slide is another picture of erosion occurring downstream at that fence line. And so really, sedimentation is a big problem.
Sorry.
So if just to have some interchange of thoughts, so what would you say the type of erosion that is existing here? We listed three. We said sheet and reel, and we said ephemeral, and then we also identified gully erosion. So with your thoughts in mind, what type of erosion do we have here? What would you say?
They might not be able to.
Okay. What I would say is that we have reel and interreeling occurring. Okay. Solutions when planning gets difficult.
Do you want me to do it for a while? Sure. I'll take over for a little bit. You know, Terry and I are back and forth here. I think it helps. Solutions when planning gets difficult. This is just some ideas. Planning is difficult because solutions to problems are sometimes hard to find and hard to fit, and it is not an easy science. And the best planners I know always are seeking input from others. Probably the one common denominator I see and I have over 30 years experience with planning, I can tell you a sign of a beginning planner is somebody that has the answers and runs with the answers. The experienced planners are always bouncing ideas off each other. So I want to encourage you to always bounce ideas off and always be open to new ideas and getting the input of the producer and finding out what are all the things that happen on this particular site that I may not know. Because when you think you know all the answers is when you're definitely at risk of giving the wrong answer. And that's just a little philosophy from Judy just that I want to share with you. So some of the solutions when planning, look at the soil unit. What unit do I need to use? And Terry gave you a little bit of insight on that. Should I split the field up? Should I use a buffer system? Should I encourage the producer to think about tillage and rotation changes? Should I introduce cover crops? And if so, how should I introduce them? Why should I introduce them? What is it about them that may be beneficial or what could be detrimental? They can be detrimental too. So do terraces fit? They absolutely do not on a good chunk of the landscape of Wisconsin, but if they fit, it could be an option. What about CRP? Are there continuous practices that might solve a problem? More grass in the rotation, is that even an option? So what's going on with this producer? What do I need to throw out there for potential solutions? We always want to make sure that we're looking at economics. We do not want to get somebody in trouble financially. And trust me when I tell you the margins are tight. We have some of the lowest predicted markets that we've seen in years. And to go along with those markets, we also have some landowners. A lot of our producers are very close on those margins of profitability. So be very, very careful when you're playing with somebody else's money that it economically makes sense to do that. And so that's why we always want it to be their idea, because we're going to throw some possible solutions at them, but we want to make sure that they make sense economically. And we also want to make sure that our agronomy knowledge is sound. We don't want to be throwing ideas at them that are not agronomically sound. So we got to know an awful lot when we're conservation planners, and that's the exciting part of being a conservation planner. And then, of course, we definitely want to be environmentally friendly so we know what we're talking about from the environmental standpoint. So we're always, as planners, looking at economics, agronomy, and the environment when we're making decisions. So Terry talks about the importance of the C factor because that's the one thing we get to play with. The C factor is the crop. What is that canopy going to look like? The more we cover the ground, the better. We all know that. So how can we do that? What is the residue going to look like in the planning decisions that are being made? So erosion will occur, and we look at those erosion rates over time. So here are some other examples with some planning considerations. We've definitely got some no tillage going on, high residue levels. Then we've got a little issue here where it appears that we probably need to take care of some concentrated flow off of the field edge coming out of this lower picture. And residue may help that. Then again, it may not be enough, as Terry pointed out. So some of the important things that we need to understand, there's a lot we need to know before we prescribe something as a sure fit. We know that continuous no-till does have great environmental results because it does reduce erosion. Compared to conventional tillage, that goes without saying, because we don't disturb that soil, the organic matter content remains high, and we've got something to cover the surface of the soil. But remember, it takes 5 years to transition into a true no-till system for most soils in Wisconsin, and that soil is important. That consolidation, or that 5-year period, is important for us to benefit from the no-till condition. So, or increasing organic matter will improve infiltration, and that's the theory that we have in saying that no-till is a good system. But if we have producers that are not able to manage for a no-till system, that may not be the right fit for that operation. So just remember, there's a downside to no-till, there's a plus side to no-till, but do understand that no-tillage is assumed to be over that long-term span of 5 to 6 years, where the soil actually has the ability to go back to its original condition. Does take that 5-year period. So we talk a lot about no-till, and look at that no-till. It doesn't have the residue, or the residue is trapping, the soil is not running off, and we see obvious benefits to it. That's been true ever since I've been in the professional environment. It's always the case that no-till has less runoff. However, we do always have to accept that there are other options available for producers, and that's called careful planning to match up. So here's an example of no-till, and of course, you know, as conservationists, that is always going to be our favorite solution to all problems, but we do have to respect that there are other options. Cover crops, fantastic solution to a lot of problems. Weed suppression, provide additional forage, soil moisture management can be profound. If we don't kill the cover crops, it can be detrimental at the early side of the season. So you have to be very, very careful and know an awful lot about it. If you're not careful, you can get in trouble with your carbon ratios. So there's a downside to everything we prescribed, and we need to be smart enough to avoid the downsides. So cover crops are great. Field borders, love to see field borders slow that water down before it hits the field or before it runs off the field, trap some nutrients, trap some pesticides. Field borders are an excellent way of doing that. Grassed waterways, I think we've all become very familiar with grassed waterways, their value, but remember, if we don't teach the operation and maintenance of a waterway, then the water can't get into the waterway. We've got all kinds of issues, so it's an ongoing battle. There's no easy cure to anything. We need to make sure that people understand how to manage the waterway once it is installed. We have a lot of different supporting practices that we can use. Oops. Sorry about that. And contour strips have always been a favorite for the state of Wisconsin, but historically, with less and less demand for hay, they get to be more and more challenging. So contour buffers have definitely got a place in our world, and that's where we can have significantly less amount of hay, 14-foot strips instead of the equal strip of grass to row crop. So contouring will always be favorable because it will slow that surface flow that Terry talked to you about across that that slope. Anything we can do to cut that slope length down, slow that water down, change that crop up on that contour is definitely worthwhile. And here again is a terrace, and of course we all know the benefits from a terrace because that absolutely will stop that length of slope. Here we have some examples of things that we prefer not to see, which is no protection whatsoever on that surface water, versus here where we have a very small protection area, but we do have some contour buffers in the mix as well. Then we have publications that just basically talk about some of the other practices, the riparian buffers where we have trees and grass next to the stream, filter strips of grass, the grass waterways in combination, the shelter belts, the windbreaks for our wind erosion sites. So the bottom line in any conservation planning that we do, we want to do the very best job, but we also want our energies to stay put. So that means that we have also very much valued our landowners' decision-making process, because when we institute a buffer system that looks like this, and it looks like this 10 years later, that's truly the best kind of conservation planning. So getting them to put this in the first time isn't the hard part. The hard part is making sure that they stay and they became a model for the entire community, and they're working. And that's called step 9, making sure that what we prescribed and what we planned with our producer is successful on a long-term basis, and that's where we get conservation ethic. So these slides really excite me when I see somebody that's been very successful at some very profoundly important conservation practices through the state. And I think if anybody ever gets up in an airplane, that's when you can really have fun looking at the true effect of conservation planning. There are sometimes you go across a state and you say, what the heck am I looking down at? You see very little conservation. And then all of a sudden you cross a border. It must be a change in the county or something. Who knows what the difference is, but you start to see those conservation practices and it gives you renewed hope. So that's what conservation planning is in a nutshell. It's making a big impact on resource needs that are obvious, and most importantly, it's convincing the landowner to do it for their reasons and to want to do it and understand why they should do it so that everybody gets to benefit from those practices. Okay, any question with anything that Terry or I have spoken about in regard to conservation planning? Threw a little philosophy in there along the way as well.
Just to make a last comment, just to echo what Judy stated regarding comprehensive planning, and so it's not that easy. It's a very complex process. And Hugh Bennett, the father of conservation, made that statement. He said it's not easy. And one example, we're looking at that no-till field. And so you as a planner, visualize yourself going out to the field, no-till, you don't see any erosion, okay? And so can you just at that point say that he doesn't have a resource problem? Well, probably not. We probably would need to do an inventory and complete assessments to determine if and under what circumstances does he have a resource problem. One of the other issues too, when it evolves around planning and addressing a resource issue, is that we need to make sure that those practices are on the landscape and he or she is practicing them year after year after year. And so, for example, if we're going to use a cover crop to reduce erosion within that rotation, well, you know what? The resource problem is not resolved for that management system where we have embedded a cover crop in the rotation if he or she do not utilize the cover crop practice year after year after year. So our theme when it comes to conservation planning is keep it green, keep residue on the surface, and keep in mind that the core practices that we need to utilize to improve, reduce erosion and soil health, and improve water quality is Practice 328, conservation crop rotation, conservation tillage, whether it is reduced till or no-till or some type of ridge till system, pest management 590, and then buffers. Buffers are key. So I just wanted to make those last comments.
I think what I want to do too, I'm hopeful that you can still see the screen. I want to leave you with a challenge, and one of the challenges that I want to leave you with is making sure that you are very closely aligned with the conservation practice standards. The practice standards come about as a result of a lot of people doing conservation planning over a very long-term basis. And every now and again we update and we improve our conservation practice standards based on findings, based on how these practices have been working. So we do make changes. They're not going to ever stay the same. And I just want to challenge you to get into section 4 of the practice standards, and I'm just going to walk you through a couple places and make sure that you do this. If you've been around a while, then you definitely know what these standards are all about. But it's the conservation practices that we want you to pay attention to, and Terry pointed you right in the right direction as far as where to go to find them. So let's look at conservation crop rotation. It's crop rotation that has a lot of influencing ability on conservation practices. So the standard itself is written, and you can open that standard up and you can look at it. And the conservation standards all tell you what their purpose is, what they're supposed to do. So these are also another way of saying these are the resource concerns that they're supposed to protect or change or improve. It talks about where the practice is going to be applied, and then the criteria is critical. Those are all the pieces that we need to pay attention to when we do good conservation planning with this conservation practice. And I just want to walk you through, you will see I do this a lot. Considerations are things that may or may not be relevant to your particular site. If they're relevant, you need to take them into consideration. If they're not relevant, for example, here it talks about pest pressures. If you don't have pest pressures, then you don't need to pay attention to that, but if you do, it's there for you. And the most important piece of any of it is these are the plans and specifications. And that is the information that needs to be addressed in order to say that you properly use that practice standard. And we really need to pay attention to the plans and specifications. Then we also need to pay close attention to the O&Ms, the operation and maintenance, because that's how we keep that practice on the ground over a period of time. It's how we manage that practice. So I wanted to be sure and share that with you and encourage you to go in there and look at them periodically. And in addition, right underneath those practice standards are the job sheets. The job sheets are designed to help landowners understand what they need to do with that practice standard. Then we also have the technical notes that are at the bottom of section 4. So there's a lot of information in there that's all really relevant to conservation planners. And remember what we said is conservation planners are the kind, good conservation planners have a lifetime ahead of you of learning, because you need to stay constantly aware of what's going on out there, so you never ever finish learning if you're a good conservation planner. And that's the exciting part of being a planner. So hopefully you found today valuable, and we're very glad that you attended this session. So thank you so very much. And
thank
Christina,
you.
special to you.
Well, thank you very much, Judy and Terry. And if anybody has any questions, they can just contact you. Is that okay?
Absolutely.
Great. Thank you all very much for joining us. And again, I'll have this recorded and we'll post this on the web. And yes, we can also just had a question about getting a copy of the PowerPoint. Would that be okay, Judy?
Absolutely. I'll send it to you right this minute.
Okay, great. We will post that as well as the recorded webinar. Thank you all very much for joining us. Talk to you soon.